Consider the following example. In this graph, the number of vertices is 5 because there are 5 points. But the number of edges is 3 at A, and then we have 3 more, so 6 edges. If I wanted to represent this as a matrix, the most natural way to order the rows and columns would be alphabetical. But you don't have to. You might have a reason to order these differently, but in that case, you should label them. So from A, there are edges to B, to D, and to E. There is not an edge from A to A. There is not an edge from A to C. From B, there's an edge to A and to D, and not to the other points. From C, I can go to D and E. From D, I can go to A, B, C. From E, I can go to A and C. Then we have degrees as well. The degree of A was 3. The degree of B is 2. The degree of C is 2 because there are 2 edges. D has 3 edges, and E has 2. Notice that the degrees are actually the same as the number of ones in a row. For example, A has degree 3. If we look at row A, there are 3 ones. E has degree 2. If you look at row E, there are 2 ones. So the matrix form tells us a lot more information than just the degrees. Now, it is common to start with degrees and then arrange them from smallest to largest. So this was done by listing the degrees in increasing order. So we have a graph and a whole bunch of different information about representing it, degrees, and so on. A lot of terminology we've learned. Now let's look at this graph and look for subgraphs. Remember that a subgraph is a graph inside of another one. So there are lots of subgraphs here that are interesting. Let me put one of them down right now. So A, B, and D are all connected to each other. If you recall, one of the special graphs was the graph where everything is connected to everything else. This is called a K3 subgraph because there are these 3 points, and those 3 points are all connected to each other. There are also some cycles in here. For example, A, B, D, C, E, A. I have put the 5 vertices in such a way that you can walk around the cycle and reach everything. Now, it doesn't look like a cycle because of the way C was drawn there, but I could have drawn C down below, and then it would have looked like a nice little cycle there. So I had all 5 points in that cycle, so we could call that a C5 subgraph. So this particular graph, it has a K3 subgraph, it has a C5 subgraph, has lots of others as well. It does not have a K4 subgraph. A K4 would mean 4 points that are all connected to each other. We can't just say that if there are 4 points, we have a K4. It matters that these 3 were actually connected to each other. Pretty much the definition there.